Now we are in lesson 6.5. In this lesson, we will first learn how to solve trigonometric equation. Already you know how to solve it algebraically. I will go over it quickly and then we will see how we're gonna solve it graphically, because sometimes they will ask you to solve even an equation graphically. Part 1 is how to solve it algebraically. So if I have, for example, the equation 4 cosine theta minus 3 sine secant theta, the secant, equal to 2 tangent. First of all, when I have an equation like this, I need to think about changing all into one function. It means either you're gonna choose to change it all to cosine, either all to secant, either all to tangent. But you know that the best is to change it to cosine because it's faster and also it's easier on the calculator. So the first one I will not touch it. Instead of secant, I will put 1 over cosine, and tangent it's sine over cosine. And then now we're gonna make it as the same denominator. So to be able to do same denominator, I will multiply the first one by cosine, the second one I will keep it as it is, and then I will have 4 cosine squared theta minus 3 minus 2 sine theta over cosine theta is equal to 0. First I have a fraction, and you know that a fraction is equal to 0 when the numerator is 0. But before solving this, I need to put the condition. I cannot solve a fraction, I cannot remove the denominator before putting the condition. Because if I will get a value for theta that makes my denominator 0, the fraction is impossible. So I need to write the condition that cosine theta cannot be equal to 0. What does it mean? It means that cos theta cannot be equal to plus or minus pi over 2. And now I will take numerator equal to 0. Again, if I look at my expression, that is cosine and that is sine, I cannot solve it when I have two different functions, as I have, for example, x and y, so I cannot solve it. So I need to think about changing one into the term of the other one. And you know already that cosine squared plus sine squared that is equal to 1. So instead of cosine, we will replace it by 1 minus sine squared. Then we develop 4 times minus sine squared minus 2 sine theta minus 3. Then I will fix my equation. I'm sorry guys for my voice. I will fix my equation, and then here now I can either use my calculator or I can do delta. And I will have two values for sine. Sine theta is equal to 0.31 or sine theta is equal to minus 0.81. And as usual, every time you have to solve a sine or cosine or any equation, you need to determine the quadrant. Since here I have sine positive, it means I'm working in quadrant 1 and in quadrant 2. So here, normally the calculator, if you put shift sign 0.31, it gives me the answer in quadrant 1. So the first one is exactly like the calculator, and the second one gonna be pi minus the calculator, or 180 minus 18, 162. And the two values are accepted. Why I wrote accepted? Because it's not pi over 2 or minus pi over 2. Now for sine theta equal minus 0.81, it's negative. So sine theta is negative, it means I'm in quadrant 3 and 4. Quadrant 3, it means the angle will be pi plus alpha. It means it's pi plus the calculator answer and 2 pi minus alpha. But be careful, I don't put on the calculator shift sign minus 0.81. I all the time just use the positive one. So I do shift sign 0.81. It will give me an angle in quadrant 1. It will give me alpha in quadrant 1. And then I will do pi plus alpha to find the first angle in quadrant 3, and to pi minus alpha. Or even I can write minus alpha to find it in quadrant 4. And also the two answers are accepted because it's not one of the angles in the condition. Now the second method is graphically. What does it mean graphically? It's easy, we use our calculator. You draw two tangent theta, and you're gonna draw 4 cosine theta minus 3 secant theta, and then after you draw, you're gonna see the intersection, but just you will take the angles between 0 and 2 pi. So I did it on GeoGebra, I didn't do it on the calculator, and I can see the 4 points of intersection. It's A, B, C, and D, and those points are in radian. Here in GeoGebra, it gives me in radian, not in degree. So you can even either convert it in degree or keep it even in radian. This is the first part of the lesson. The second part, it's the differentiation trigonometric functions from first principle, or we say the first derivative. So what does it mean differentiation? I said I derivative, and we're gonna do it using the definition of the derivative. So as we know from chapter 4, that what does it mean derivative of a function at a point? The derivative of a function at a point, it's the slope of the tangent at this point. So if I have a function y, or I can name it f of x, we say dy over dx, it means the derivative of the function with respect to x. And also, guys, I can write it f prime of x. You can see this notation. The derivative definition, it's the limit of f of x plus h minus f of x over h when h tends to 0. Why do we have this definition? If you look here, you can see that as I'm saying y2 minus y1, and down it's the h, it's x2 minus x1, so it's approximately it's the same formula at the slope. So let's do the first example. I need to find the derivative of f of x equals sine x from first principle using the definition, because later on we will learn the formulas. But sometimes I will ask you to use the definition to find the derivative of function. So by definition, it's limit of f of x plus h minus f of x over h when h tends to 0. When I say f of x plus h, it means sine x plus h, because the function is sine x minus sine x over h. And now I will use the formula also from the preceding chapter, sine a plus b. What is sine a plus b? Sine a plus b is sine a cosine b plus cosine a sine b. So it means it's sine x cosine h plus cosine x sine h minus sine x. Now if I took this term, guys, and this one, I have a visible factor, it's sine x. So it's sine x factor of cosine h minus 1 plus cosine x sine h. Now I have a sum of, be careful, it's limit of a sum. So when I have a limit of a sum, I can do it, it's a sum of the limits too. So I can separate them. It means I can do the limit of sine x cosine h minus 1 over h plus the limit of cosine x sine h when h tends to 0. Now, for the first one, sine x is not related to h sine x as it's a constant, because it doesn't change when h tends to 0. Who is related to h is cosine h minus 1 over h. So it's here it works as it's a constant. So if I have a constant, I can put it before the limit. So if I have, for example, limit of 2x is the same as 2 limit of x. So here sine x, it's a constant. So I can write it here, sine x times limit of cosine h minus 1 over h plus exactly the same here. Cosine x, it works as a constant. So cosine x times limit of sine h over h. Now, those rules are from chapter 4. We know that limit of cosine h minus 1 over h when h tends to 0, or cosine x minus 1 over x when x tends to 0. This one is tending to 0. And this one is tending to 1. This is a rule from chapter 4. So I will have sine x times 0, so the answer is 0, plus cosine x times 1. So what is the answer? Cosine x. It means the derivative of sine x is cosine x. Now let's move to the derivative formulas. Also, I'm doing a recall from chapter 4. The general formulas, f of x is equal xn, the derivative f prime or df over dx, it's nx minus 1, and there is an example. If I have x4, so it's 4x3, so I take the exponent down and I do minus 1. I have also, if I have an expression un, it's nu prime un minus 1. If I have a product u times v, it's u prime v plus v prime u. If I have a fraction, it's u prime v minus v prime u over v squared. And if I have a radical, it's u prime over 2 radical u. And also the radical, if you don't remember the formula, you can do it as an exponent. You have, and you can go back to the formula of u n. The derivative of sine u, it's u prime cosine u. Derivative of cosine u, it's minus u prime sine u. So those are the formulas that I was talking about. Sometimes I will ask you to use the definition of the derivative to find the derivative, or using the formula. It's linked to the question. The derivative of tangent u, it's u prime secant squared u. And also you can find it by replacing tangent by sine over cosine, and you use the formula u over v. So you do u prime v minus v prime u over v squared, and you will get the same answer. The derivative of cotangent u, it's minus u prime cosecant squared u. I still have the derivative of cosecant u, it's minus u prime cosecant u cotangent u, and the derivative of secant u, it's u prime secant u tangent u, and it's also, guys, you can use the quotient formula as I'm doing here for tangent. If the question is find the derivative of tangent x using the quotient rule, so I will replace tangent by sine over cosine, and now I'm u over v. The formula of u over v, it's u prime v minus v prime u over v squared. And now I will use the formula. U is sine. What is the derivative of sine? It's cosine. V is cosine. All the time do it this way, so we'll not do any calculation mistake. It's minus sine, and then now it's u prime v. So it's cosine times cosine, it's cosine squared, minus sine x times minus sine x, it's minus sine squared x. So it's cosine plus sine squared over cosine squared. It's 1 over cosine squared. This one, we know this formula. So the answer is secant squared x. This is what I was saying here, so that you can find it from this one. And I have the last example. I have sine x times cosine x. It's u times v. So u prime v plus v prime u. If u is sine, what's going to be u prime? Cosine. V is cosine. V prime is minus sine. Now, u prime v. So it's cosine squared minus sine squared. And this one, also the formula we know from the preceding lesson. It's cosine to x. Guys, as you know, every time we will do more practice in the class. It's just the video, it's just a summary for the lesson. How do you use the definition of the derivative? We will do sure more practice in the class. And how also use the formula of the derivative. We will be also doing more practice. Watch well the video. If you didn't get it, repeat it well. And see you next time in another video.